Before we get started today, reminder of how to find circumference. Again, the difference between circumference and area. Area is how big a circle is. Circumference is how far around a circle is, or how big around it is. So if you got a circle, you want to find the distance from point A to around to point B. Okay? Distance all the way around that circle, use the circumference formula. Circumference is equal to pi times diameter. Or if you, instead of wanting to use diameter, you want to use 2 times radius, because the diameter is 2 times the radius. You could also use circumference equals 2 times pi times radius. The same formula. Thank you. What if you have a radius, let's just work the problem. You have a radius of 4. The circumference, the distance around, would be pi times diameter. If the radius is 4, Riley, what's the diameter going to be? If the radius is 4, the diameter is, if the radius is 4, the diameter is 8. So pi times diameter would be pi times 8. That's the circumference. That's the exact circumference. I think 25.12, you actually want to multiply by 3.14, I think around 25.12 would be the approximate diameter, okay, with a radius of 4.
Yeah, that's right.
But what we're going to do is arc length. I've worked them so many times. What we're going to do is now arc length. We don't want to find the distance all the way around. We want to find a partial distance, and it's going to be just like how we found the area of the circle or area of the sector before. What if we don't want to find the distance all the way around the circle? We only want to find the distance cut off by a 40-degree angle. We want to find the distance from here to here. Well, what you need to remember is there's 360 total degrees in a circle. And if you've got a 40-degree slice, instead of going all the way around the circle, you're only getting a fractional part of that distance. Okay? How much? If there's 40 degrees from here to here, well, the whole distance around is 360. So you're going this fractional part. Does everybody understand that? You're going 40 degrees out of the 360 degrees. If you reduce that, you actually get 1/9. So do you know what that tells you? That there's 9 of these slices in the circle, and this is not really drawn to scale, but there would be 9 of these slices in here. So what I could do, if I want to know the distance from here to here, well, could I not find the whole circumference, which would be the distance all the way around, and just take 1/9 of it? It's the same way we did sectors yesterday. Find the area of the whole thing, and then take the fractional part. Same way with circumference, or with the arc length here. Find the distance all the way around, and then just take the fractional part that you need. Here's some problems. Find the length of each arc. On the first problem, you have a radius of 5. And guys, honestly, circumference should be pretty easy to this. Circumference, I'm going to write at the top. Circumference is pi times diameter. Jagger, help me with this one. What's the diameter of this first circle? Careful. Radius is 5, diameter is 10. So therefore the circumference, folks, pi times diameter, 10 pi, 31.4. Okay? That's the distance all the way around. We don't want all the way around. So what you're going to take, you're going to take this fractional part. We know there's 360 total degrees, but we only want this part of it. We only want 53/60ths. Okay? 360 total degrees, we want 53/60ths of, remember what of means? That total circumference. So what you can do, and you can do this one of 2 ways. If you want an approximate answer, you can just type this straight in. If you want an exact answer, you're going to have to take and reduce this. I'll show you exact first. Let's see, you can always just cross off the zeros, right? That's 5 over 36. And I don't think that's going to reduce anymore. Times 10 pi. And that's going to be 50 pi. Well, actually, we could reduce that 4 to multiply, can't we? 36 and 10 reduces to 5 and 18, which gives you 25 pi over 18. That's the exact arc length. The approximate arc length, look how easy this is to type in. Clear? 10 pi is my entire circumference. It's a distance of, let's say it's in centimeters, it's a distance of 31.4 centimeters all the way around. But we only want a fractional part of it. We only want 50 divided by 360. We only want that fractional part of the previous answer. So you could just type that whole thing, and if you wanted to, we want 53/60ths of 10 pi. So the distance from here to here would be 4.36. Does that look kind of right? If the distance from here to here is 5, if you curled that around that, doesn't that look a little bit less than 5? Can I say that? Second one. Same thing. Pi times diameter, or at least not here. Buildings. Hunter. What's the circumference? Exact circumference here. Pi times diameter? 14 pi. That's your exact circumference. But you don't want the whole exact, or you don't want the whole circumference. You only want, again, it's the same fraction actually here. You only want 53/60ths of that. Let's go straight to the final answer. 53/60ths of 14 pi. Some of you already typed them in. Check and see if you get the same thing I do. You're going to get 53/60ths of 14 pi. About 6.11. That makes sense. About 6.11 centimeters. There you go. 53/60ths, that's the fractional part. That's the portion of the circumference you need. So you do this portion of means times. This portion of the circumference. 53/60ths of the 14 pi is the portion you're looking for. So it's going to be 14 pi, which is around 45. 45 centimeters all the way around, but we only want this portion of it. Okay? So these are pretty easy once you learn how to do them, right? The last one, Briley. What's the whole circumference exact here? It's the same thing, isn't it? Careful, pi d. So 14 pi. 14 pi is the entire circumference, but you only want this portion. You only want 100/360ths of the 14 pi. So you just type that straight in. 100/360ths of 14 pi. And I actually, on these calculators, let me show you a trick. Oops, that didn't help. If you do your second button, and right above enter, you've got entry. If you do second entry, it brings up the last thing that you typed in. Because I noticed on this problem that instead of 53/60ths, the only thing I'm changing is 50 to 100/360ths. So I can do only thing it's going to write over what I wrote before. So how in the world am I going to get another 0 in there? This I and S, if instead of typing over it, you want to insert something, hit that I and S, then it'll insert it for you. 12.22. So about 12.22 centimeters is the distance from E to L. That's that arc length. Okay? This is not, here, we need to know this. That is not the distance from here to here. It's the distance of that curve. Now, how in the world do we find the distance from E to F? Well, that's 7. This is 7 because they're both radii. You could do the law of sines, law of cosines to find the distance from E to F. The distance from E to F should be a little bit less than 12.22. Okay. I think that's enough of those. Actually, no, let's work this one. Because I see here 30 degrees. Can somebody tell me what fraction, without writing it down, just do it completely in your head? 30 degrees. What fractional part, or how many of these slices are in this whole circle? If that is a 30-degree segment, there are 12 of them. 360 total degrees. If you multiply 30 times 12, you get 360. So pretty much you're just looking for 1/12, right? 1/12 of the entire circumference. What is the circumference of this? 16 pi. Pi times diameter. 1/12 of that you could reduce. That gives you a 4 and a 3. That's going to be 4 pi over 3. And you could actually take and multiply that together. 4 times 3.14 divided by 3. 4.18. So,
4.18.
12.56, 4.18. So we said 4.18. 4.18 units. It's not, doesn't have the units there. So about 4.18. Now let's work it backwards. Let's do this backwards. When we get to pre-calculus, you don't understand how much of this we do again. What we're doing now is going to help you tremendously when we talk about sine, cosine, and tangent and the XY axis and degrees bigger than 90, 180. So here we go. Find the indicated measure. I want the circumference of this circle. The circumference of the circle is the distance all the way around the circle, and all they're giving you is an arc length. They're telling you the distance from Q to P on that arc is 3.82 meters, and they're giving you that this is a 60-degree angle. How many 60-degree angles are in a circle? If you took 360 degrees total, and this is the process you would work. And here's my advice for you. 60 degrees works nice and neat. What if this was 50 degrees? Go through the process and work it like it was 60. See the process you would go through, and then you would go through the same process with 50. Now, how did I come up with there's 6 of these in a circle? I took the whole 360 and I divided by 60, and I got 6. So there's 6 of these slices in here. So therefore, 3.82 is the distance from here to here. Since there's 6 slices, yeah, good job. Just multiply that by 6. And your whole circumference is going to be 19.
3.82.
Yeah. And that should be exact, right? That's not approximate, because if that 3.82 is exact, then the 22.92 is exact. Now, again, if that changed to 50, you couldn't do it in your head anymore, right? So what if this was just a 50-degree angle? How would it change this problem? Right here is all we do, guys. You would divide by 50, it would give you 6 point something, you would do the exact same process. Okay? Now the second one. We're looking for the measure of arc XY. The measure of arc XY. 18 inches, what is 18 inches there? Is that not the measure of arc XY? I see what they're asking for. They want an angle measure. That's what, because I'm thinking that is the measure, right? Let's look for the actual angle. I think that's what they're going for here. Okay, 7.64. That's your radius. Okay, now let's find the distance. Let's find the whole circumference here. Circumference is equal to pi times diameter, which 7.64 times 2, that's going to be 15.38. I think. Check me on that. So pi times 15.38. Somebody multiply that out for me. Actually, so that I have it exact, let me do it right here.
48.29.
48.29. So it said 48.3. Oh, you used 3.14, so you 5, but that's fine. So that's the distance all the way around. But what I want to know is what portion, and what's real close on this, guys. This is a little tough what we're about to do. I want to know that's the distance all the way around is 48.32, but what portion do we have here? We have 18 out of those 48.32. Y'all understand that's a percentage. That's a fractional part. We have 18 of the 48. I want just, normally I'd use the answer button, but I want to put it here to where you can see it. 48.31769, or 31770. That's the fractional part that 18 represents. Okay, it's not the whole circumference, it's this portion. We'll hit enter and look what happens. You know what that right there is? That's the percentage that you have of the whole circle. We don't have all the circle, we have about 37% of it. So if we want to find out what this arc measure is, what this actual angle here, this central angle is, Well, how many total degrees are around the circle? But we don't have all 360, right? We have 37% of those 360. So how do I find 37% of the 360? Take this number and multiply by 360. That's about 134 degrees. Let's go through that process again. Let me help you understand. First step, I found the entire circumference by doing this, pi times diameter. Once I found the entire circumference, I asked myself, well, what does this arc represent? What portion of the entire circumference does that arc represent? And it's going to be 18 out of whatever the circumference was. As soon as you take and divide that, 18 out of circumference, as soon as you divide that, that shows you the percentage that arc is of the entire circumference. And now that you know what percent this represents, you can find what angle it is, because there's 360 total degrees. Well, this is a certain percentage of the 360. Multiply it, because all means times, and you've got your arc. Let's do another couple of those. Let's actually, the first one, first one's like what I was talking about a while ago. It's not as easy. We need to know how many segments or how many of these there are in the entire circle. Well, I know there's 360 total degrees. Well, I need to know how many 55s are in 360 degrees. And we get 6.54. I'm going to do it right here just so I've got it on my calculator. So 360 divided by 55, there are 6.54 of those. So about 6.55 of them in the whole thing. Well, 5.5 is the distance from here to here. But there's 6.55 of those 5.5s all the way around it. So just multiply that answer that you got times 5.5. And that would be the distance. That's all. That comes out to be even. That's the distance all the way around the circle is 36. Okay. And the second one, like I said, these are tough. These second ones here, they're not easy. I want to know the radius. Well, actually, this one's backwards, isn't it? I want to know the radius of this circle. We're given that an arc length of 42.56 from here around to here. The arc length of LM, actually, that needs to be named with a third dot because that's a major arc. So what I'm going to do, I don't like the way they did that. I'm going to put an N right there. The measure of arc LMM, the distance, the arc length is 42.56. That represents 240 degrees of the whole thing. We need to know what the radius is. Well, here's what I would do. I want to know the distance all the way around. Because if I know the distance all the way around, the circumference, well, I know the relationship between circumference and radius. But I don't know the relationship between that and the radius. So first off, we need to know what portion 240 degrees is of the whole circle. 240 degrees represents this portion of the whole circle. That's, if you reduce that, if you want to, it's a third of the circle. Actually, it's 2/3 of the circle, right? So if that's 2/3 of the circle, here's my thought process. This is just, and I know I work things different than a lot of people do. If that's 2/3 of the circle, taking half that. Why would I half that? First step, taking half 42.56. Yeah, why would you do that? When you half it, what have you just done? When you take half of that, now that represents one piece, 1/3. Well, if it represents one of the thirds, let me draw that. If I half it, I get 21.28, and then you multiply that by 3, that's the circumference. That's the whole circumference. So somebody do that for me. Half it, 21.28, multiply it by 3. Actually, let's see, that's 63.80. Good job. That's your circumference. That's all the way around the circle. But we want the radius. Well, what's the relationship between the circumference and radius? The circumference is equal to 2 times pi times the radius. So how do I find the radius? You take the circumference and you move this over. You would. since these are being multiplied, you would simply take your circumference and divide it by 2 pi. And you get 63.84 divided by 2 pi. 3.84 divided by 2 pi. No, I typed that in wrong. Okay, you got to be cautious about the way you type these in. The way I typed it in, my calculator took 63.84 and it divided it by what? 2, not 2 pi. And then it took my answer and multiplied it by pi. Make sure as you type this in again, second entry brings that up again. You want to divide it by that whole thing, so you better put 2 pi in parentheses. So you don't make, yeah, 10.16.
Do 1.5 times 42.56.
1.2, say it again.
What I need to say, 1.5 times 42.56.
You could do that. You could do that. He said he took one, because 1.5 times that, well, this is 2/3 of it. You want another one, the whole one of this and another half of it. You could do that, and that would give you that whole circumference as well. Good job. Yeah, either way would work there. Let's get that one. Here we go. Got this odd looking shape. And you're asked to find, ignore the exercise 30 through 32. The region is bounded, this region is bounded by circular arcs and line segments. Find the perimeter of this figure. Perimeter, again, guys, is distance all the way around. Okay, so what if we had a running track and you've got a distance of 2 miles, and then this distance, what's this distance here? 2. 2. So we know these. But the problem is, I don't know the distance from here around to here.
Since the whole distance is 6.
The whole distance is 6, but does that mean the distance from here to here is 2, or the distance from here over to here is 2? That's 2, and then this is 2. Do you see that if you took this, okay, all that is a quarter of a circle. It's a 90-degree angle. Good job. But the problem is, what's the radius of that circle? It's 2. Imagine this as being the center of a circle. Finish that circle out. So all you're looking for to find the distance from here to here is you're going to take the circumference of the whole circle and divide it by, careful, this is a quarter of the circle. So you're going to divide it by 4. But you know what? Think about this. You've got one here, one here, one here, and one here. So is that not just going to be the whole circle? The distance from here to here, yeah, we'll go through the process. You've got a radius, since the whole thing is 6, that makes this 2 and this 2, the radius is 2. Making the circumference pi times diameter, 4 pi, which is 12.56. Right? That's the distance all the way around. We don't want the distance all the way around. We only want the distance from here to here. Well, if the distance all the way around is 4 pi, what's the distance from here to here? 1/4 of it for a single pi, 1 pi. So what you got, the distance from here to here will be a pi. The distance from here to here is a pi. Distance from here to here is a pi. Distance from here to here is a pi, which is going to be that same 4 pi again. So what is the circumference, or excuse me, I'm not going to say circumference. What is the perimeter of this shape? Well, you've got 2, 2, 2, and 2, which is 8. Plus the distance from here to here, here to here, here to here, and here to here would be 4 pi. That's the exact answer. 4 pi plus 8, which is about 20.56. Any questions? I think we got time for about one more. In these exercises, the region is bounded by circular arcs and line segments. Find the perimeter of the given region. There's last year the statewide math competition we go to in Tuscaloosa had a problem very similar to this. Talked about logs on the back of a truck being tied down and how to find the distance all the way around. We'll work it later. Let's work this first one here. I don't know what's the distance all the way around this. Okay, you got this odd looking shape. Well, I know from here to here is 12. And I know from here to here is 12. Because it gives me tick marks. But I need to know how far is it from here around to here.
What's a half?
That's a half circle, right? So let's draw a whole circle. And I wanna know what's the distance from, this portion is the distance from here around to here. What's the radius of the circle? 3.5, but honestly, we don't even need radius, right? Because pi times diameter is our formula. Diameter is 7. So how far is it from here to here? Actually, first off, what's the circumference? Pi times diameter? 7 pi. But we don't have the distance all the way around. We have a half circle. So if it's 7 pi all the way around, this half circle would be 3.5 pi. And how far is it from here to here? 3.5 pi. So the perimeter of this shape, you've got 12 plus 3.5 pi plus 12 plus 3.5 pi, which I believe would be 24 plus 7 pi. That'd be the exact. That's what we're going to be looking for. Cross